are very much same. But then also my model is not working accurately. It is working very good on the training data set. But when it work on some new data set, which is not seen by my model, then my accuracy is very, very bad. This is a case that we call as the overfitting. So this is what I was discussing about. Sometimes it happens, for example, you have increased so many, epochs, you have increased so many layers, you increase so many number of nodes. It is showing me artificially that accuracy is very good. But when I work on the unseen data, my accuracy is very bad on the unseen data. This is the same case I was telling you. For example, I have given you same set of questions for the practice and same set of questions, exactly same question I'm giving you on the test. So it may be possible some of you remember the answers, and in spite of instead of solving it, you are just tick marking the answers because you already know the answers. So in that case, your teacher is able to check your efficiency? No. She will get a false accuracy. And when it comes to some final exam, you go outside the school, you won't be able to perform well. Okay, so I hope now overfitting is clear to everyone. So sometimes we have to check for overfitting also. Okay, so let's start with one example. Great. So if you want more information about it, you can just go through these articles also, right? These are the figures which are underfitting, showing underfitting and overfitting only. So we need to have a balance between underfitting and overfitting. Sometimes what happen, excuse me, sorry. Sometimes what happen, I have trained my model on a very less data. Okay. So is it fine to train my model on very less data? Will it work perfectly when we actually use it with my testing data or with my real data? Yes. Is it okay to train? No. So there should be some limitation. With this much data we must have. Okay. Now let's understand this overfitting and underfitting with respect to two algorithms that we have already done. That is KNN, K nearest neighbor, and the decision tree. Okay. Okay, let's start. I think I have uploaded my data. Yes, it's here. Now let's start. Okay, what I need to copy the path. You don't have to do when you are using your Jupyter notebook. But then also you ensure your ISO data is in data folder. If they are in same folder, then you also just remove this. Only keep IRIS.data. Okay, if your notebook and your data are in same folder. Right now I'm using Colab, so I have to get this. Okay. You can use Drive also. You can just check for it, but you have to mount your Drive over here in the Colab. Right? So nothing new up to here. Yes. Here what I am doing. Can anyone write down what I have done here? This is the same thing. I think I am doing it 10th time. What I am doing here. Can anyone write down in the chat what I am doing here? Label encoding. Yes, Siddharth. Label encoding. Yes, IRIS data. I have done the label encoding. And again, for Setosa, I kept 0. For Versicolor, I kept 1. And for Virginica, I have done 2. Great. So this is how the distribution is done. This we have done so many times. Okay. We need to split our data. This I have shown you in the previous notebook. So for this, I import train underscore test underscore split. And here I have done the split. My test size is 0.725. So what is my distribution? Training versus testing. Can anyone write down in the chat? Training versus testing. What kind of distribution I have done? Anyone? 75-25. Exactly. 0.25. Now the next task is to standardize. So now I think you are able to remember the steps also, right? So I have standardized my data. It's always better to standardize your data. Now I'm using the KNN, that is K nearest neighbor. And here, what I'm doing, I'm just checking. It's not clear to me how many neighbors I used to keep. Okay. How many neighbors are needed? Just check. I think the default value is 4 or something. You can just Google it. Okay. Now I can also define how many neighbors I want in my algorithm. And for this, when I'm defining my model in the bracket, I can give n underscore neighbor and then whatever the neighbors are there. Okay. But I'm just confused how many total number of neighbors I should take. So how I will get away from my confusion? Anyone? How I decide how many number of neighbors I need? Anyone? I know this is a loop, but how I will decide? Anyone? Yes? I want more answers. By checking accuracy in different values. Exactly. Exactly. Okay. The default number is 5. I was just checking it on Google. 5. Okay, but I want to check with accuracy. Okay, so that's what I'm doing. I'm just varying II is just a variable, and I'm varying it from 1 to 16. So first of all, I will keep number of neighbors 1. And then I will check what will be my accuracy. Then I will keep 2, then I will keep 3, and I will keep on running this loop up to which value? 16 value. Okay, so let's try this. So for this, I'm keeping 2 lists also. One is keep on storing the accuracy, and one the number of neighbors. Okay, now let's run this. Okay, now can you see? First of all, I have initialized my model, then I'm training it, and then I'm checking the accuracy. And how I check the accuracy? Someone was asking me previously. For checking, we use the function dot score. Okay. So let's do it. Now it is giving me the values. Now you see, when the neighbor is 197, you can multiply it with 100, you will get the accuracy, right? You get 97% accuracy, again the same accuracy, again the same accuracy, fifth also same. But when you come to sixth number of neighbors, you get accuracy 100%. Yes, Siddharth. And after that, my accuracy is reducing. So it's difficult to understand like this. So let's plot a graph. So it will be easy for you to understand. So here I have plot. Ma'am, I'm not getting the output. Levin, we will just check it. I will just share the course notebook with you. You're not getting this accuracy. Is this one you're not getting, Levin? Levin, what you are not getting? Are you printing it? Let me copy this code for you. And I'm just keeping it here in the chat. I think it's there in the youth notebook also. Is it there in the youth notebook? Yes. Okay. So I hope now you got the output. Yes, Levin? Maybe you just missed this particular line. Okay. No problem. I have just shared this notebook. I've shared this notebook. No, is it there? Is this notebook is there? Is this notebook is there in the drive link? Yes, it is there. Don't have the code in there. How is it possible? This is not possible. This code was there. This code is there. Siddharth, can you confirm this particular code is there? Print accuracy. Yes, it's there. Shaunak is also saying. Okay, just focus over here and then focus over here. Okay, let's plot it. And can you see in this plot? Up to neighbor 5, the accuracy is somewhat same. But when number of neighbors are 6, the accuracy is 100%. Okay. So what should be the value of neighbors that we must take? Anyone? Because after that also it's got decreased. and then we come to 12. So again, it become 100%. So what should be the number of neighbors that we should assume here? What is your idea? 6. Yes. Okay, the first one where I got the maximum accuracy, I should take that only my number of neighbors. So I hope this much is clear to everyone. Yes, is this much is clear to everyone? Okay, thank you, Rimsha. So I'm just giving you here a pause of 2 minutes. You can tell me, are we good to begin with the decision tree? Okay, in the decision tree, what are the different things that we can assume? As we discussed last time also, what are the different parameters that I can pass in decision tree? Just think about them. Anyone? Just think about them. In decision tree, what I can pass in decision tree? Any idea? Should I only tell? Don't worry if you're not able to execute it. I will give you the complete notebook. Okay. In the decision tree, there are two things that I have to manage. Now, what are that two things? The first thing is, what is the depth of my decision tree? Okay, depth means how many levels are there in which I'm taking the decision. This is one thing. Second thing is, for example, if you remember that decision tree, okay, let me open that figure. Give me 1 minute. Let me show you one example. Okay, you remember this? Are you able to see this? Yes, are you able to see this? Yes. Now, at how many levels the decision are being made? Anyone? What is the depth of this tree? Can anyone tell me? 7, no. What is the depth of this tree? This is, yes, 3. Very good, Siddharth. Yes, Varnika. This is level 1. This is level 2 and this is level 3. At 3 levels, we are doing the decision. Okay. Now, for example, I'm just considering weather and I have just 2 data points. One is saying sunny and one is saying rainy. Can I rely on these 2 data points only to take my decision? Can I? Yes? Any idea? No. Otherwise, it will lead to overfitting, isn't it? So at least there should be some minimum level over here. For example, I want at least 50 points should be there so that I can do a decision. Okay. So two things I can set, I can manage in my decision tree. One thing is what is the depth of my decision tree. If there is too much depth, then also what will happen? Anyone? If there's so much depth at so many minute level, micro level, I'm taking the decision. What can be the chances? Again, it can lead to overfit. Yes. So we have to be very careful for overfitting and underfitting. Yes, low performance will be there, right? So one thing is what should be the depth, and another thing is at how many data points the decision is to be made. Clear? So let's go back to my code only. The theoretical background, the knowledge of theoretical background, what you are doing, why you are writing this code, this is very, very important. Okay. For the project also, I will give you some suggestions. Just give me some time. Okay. So decision tree, I've already shown you. So again, I have taken, first of all, let's work with the depth. Okay. Now, when I work with the depth, accuracy equal to, I have just taken two lists. Accuracy is blank, depth is blank. Right. Now I am giving different values for my depth and then I will keep on checking my accuracy. So for I in range 1, 10. So I'm varying my depth from anyone? I'm varying my depth from which to which value? Anyone? I just need to, just 1 minute. See, you have to execute the code from the beginning. Otherwise, it will give you some error. Like here, it is giving some error. Let me check. No, it's working properly. Right. Okay. So I'm working on the depth. So I'm ranging the depth from 1 to 10. Then I have initialized my model. And every time I'm changing my depth, then here I'm doing a training. And then here by using dot score function, I'm reading the accuracy and I'm appending the depth and the accuracy in these lists. Now see what is the output I'm getting. Okay. Soumya, you want to ask something? Yes, Soumya, go ahead. Yes, please type your query. Type your query, Soumya. In between, let the Soumya type her query like this. Now, can you see? It is throwing an error. See, you have to execute from the beginning and please put that error, the last line of the error in the chat. I will just check it. First of all, just focus here what I'm trying to do. Okay, just wait. So here, can you see? It's giving the accuracy 97%, again 97, 97, 97. At this position, it is giving me 100%. It's difficult to analyze like this. So what we can do? We can create a graph. Tree is not defined, then you have to just wait. You have to import this library. I'm just showing you at the top. I think you have not imported the library. Tree library you have to import. In the beginning only it was there. Here, from sklearn import tree. Okay, this you have to run the code. Soumya, then you don't get this error because it is not finding the tree library. Got it? Hidey, just wait. Let me show you this graph. Okay. Showing some error. Oh, okay. I think I have not executed the whole code. So let me execute the whole code. Give me a minute. Okay. This I have done. You also, I just suggest everyone to just execute the whole code. Okay. Standardization is done. And I have calculated the accuracy for KNN. Then I have plotted the graph. Now let's do for decision tree the same thing. This is done. Let's plot the graph. Again, showing some error. Okay, no problem. Let me explain this and then I will look for the error as well. Okay. Okay, I think here it should be accuracy. Okay. And then do this. Okay. The spelling mistake. There's some typing error is here. Okay. Now, can you see what is showing when my depth is 2, then it is showing me around 100% accuracy. Okay. The accuracy got reduced due to some reason. So what should be my depth? If I take this particular scenario, then my depth should be 2. Okay. Okay, but in my previous calculation, my depth should be 6. But now I think some changes is done. The accuracy got reduced so much. So you can just do it once again. It should be 2. That's great. Yes, the maximum value will be 2. That's okay. Now, what is the next thing that we can manage? Number of data points at which the decision is to be made. Okay, so for this again, I need 2 lists. One is accuracy and one is minimum number of samples. And minimum number of samples, at least 2 should be there. Then only the decision can be made. We can't do a decision on 1 data point. So I'm just varying my data points from 2 to 16. And again, I'm training my model and I'm just checking the accuracy. Okay, so this is the accuracy that I received, 97. And then it's reducing after 97. Can you just check? It's reducing, and after that, again, it has increased. Now, can you tell me what should I take here? What should I take as minimum samples? Anyone? Any idea? What should be taken as minimum samples? Should I take 2 or should I take, this is what, 6? What should I take, or 7? What should I take? What is your idea? 2. Okay. Don't you think 2 is very less? Don't you think the 2 is very less for taking a decision? Isn't it? If I take 4, then my accuracy got reduced. So when I'm going to get the same accuracy, I'm going to get the same accuracy at 6. So instead of 2, we will go for 6. I hope it's clear to everyone now. Yes. Okay. Now, are you able to execute this code? 24, I'm not checking. I'm just checking up to 16. So I don't want to go into so much depth. In so much samples. So I just fixed it to 6. But 2 is very less. So that's why we are not going for 2. Okay. Is it clear, Myra? Yes, Rimsha, Hitesh. Very good. So I'm just uploading this also. Okay. Just give me 1 minute. And the link which is shared by Anup sir. So there also, this particular notebook is there. So I'm just inserting this one also. No, I think this is a wrong link. Just give me 1 minute. Just give me 1 minute. Sorry. This is the link I have shared with you all. Yes, thank you, Hitesh. But here I am uploading. This is the link that I have shared with you all. I hope you're downloading it in your computer or keeping it somewhere in your Google Drive. Because after the session, after completing the whole bootcamp, that link, the files won't be available to you. Okay, I hope it's there. Now, I'm open for your queries. Please go ahead. Siddharth has done. What about rest of you? Are you there, sir? Anup sir?
Yes, sir.
Okay, no, I did not understand, ma'am. Harshit, please write down your query. Harshit, please write down your queries. What you are not able to understand, Bhavesh has done. Otherwise, I'm handing over the session to Anup sir.
Those who have joined in the session, thank you, Shilpa ma'am, for this session. So students, as we are nearing the end of this bootcamp, all of you are have understood and are practicing most of the, what you can say, Python codes, how not only to acquire data from different sources, how you can explore, how you explore the data. Once you have explored the data, what are the next steps in model building, and how you create your model. Okay, a simple model or a new neural network based model, and then how to check model for its accuracy, how to check whether the model is having some issues in underfitting or it's overfitting. Okay, and tomorrow you will also understand how you can optimize your model. Siddharth, how we can deploy the model. So for the model deployment, you need to create a user interface. There are some websites. Okay, you can use Flask. Okay, platforms like Flask. There is something known as Streamlit. You can explore these by themselves, by yourself, and then you can create what should I say? You can create an interface on any one of them. These are very simple, okay, platforms. Great, Ishan. So Ishan can be a point of reference for all of you, those who want to are interested in deploying their model, how to work on Streamlit. It's a simple, very simple platform. Okay, minimal of Python coding is required, and then you can convert your entire Python-based model into the platform where you can just as per the need and requirement, you can have certain parameters, certain values to be filled, and it can do the rest by itself, prediction, etc. Okay, now let us go into the project discussion or the idea discussion. Okay. Okay, so Hitesh, ma'am also mentioned the same thing. What I've said. Well, please don't use caps lock. When you are chatting with someone or when you are messaging, it is considered as writing in caps lock is considered as a bad manners or a bad etiquette, as if you are yelling on someone. Yes, sir, can you arrange platform that we will see if time permits? I will just give you a overview of Orange platform. Yes, great. Sir, should we also explain our code on our project model? See, when okay, so let me just clarify the air around now. Okay, so no more queries in the chat. Let's just listen to me now very carefully about the project. After that, we will be going one by one, and you will be sharing. I will be giving you the time to discuss, share about the project ideas. Yes, I have already downloaded the list of the ideas that all of you have submitted. It is on the screen, and I will be providing a 2-minute time to every one of you. In all, there are 91 students who have submitted the ideas. Some of the ideas are in pairs. Okay, so the number of students may be 95, 96 around. Okay, every individual or a group will get a 2-minute time, that is 120 seconds, wherein you will have to just explain your problem statement, the context. First, you will talk about what is the context and what is the problem statement. That's it. Okay, in 2 minutes time. Now, let's talk about the when you will be converting this problem statement into a working model or a project. Yes. So, what do we mean when I say working model? Working model is, as first it was Sunita ma'am, now it is Shilpa ma'am, who have given you a good insights into how you work on a notebook using different, what you can say, different codes. Now, since the very beginning, when we started the notebook, you must have observed that there is a set pattern that we are following, and this pattern is very much aligned with the AI project cycle that that we discussed around. So when you will be developing your model, obviously the problem statement which all of you have given now, or we will be discussing, that means you have more or less achieved the first stage of AI project cycle, that is the problem scoping part. Once you have done with the problem scoping part, the next step is about your collecting the data. So if you have uh, uh, cited your problem, you must have also what you can say cited the from where you will get the data. As I mentioned on the day I explained ideation, when you will be thinking about your project, you also need to think from where the data set will be acquired. Okay, so that means I am presuming that all of you who have submitted their idea, you are also having a data set along with it. Now, so that means the two stage of project development are almost over at your end. The third stage, that is the data exploration. If you remember, you worked on the notebook around erroneous data, missing values, graphical representation of the data, that is data visualization. Yes, all these are stages of your data exploration. So when you start building your converting your problem statement into a model, so you will be working on a Jupyter notebook. Okay, your model will be submitted as a working code model in a Jupyter notebook. The flow will be, first of all, obviously, you will import the libraries. Now, when you work, you don't know what all libraries will you require. But as you proceed, you will be requiring different libraries. So what you do, the first cell, obviously, see, I will be sharing one project with you, okay? Just to give you an idea how we proceed, yes? Okay, so let me just give you let me just share one project with you, okay? And then I will come to the discussion point, a discussion of your ideas, okay? Because I don't want that once we have discussed and then you people just keep means like what could be the project, okay? How you are going to follow, what should be, how you are going to present the project, yes? Now just I'll just give me 1 second. Let me open a Jupyter notebook for you people. Yes. And I will share one more project that has been done. Okay. Just to give you an idea about. Okay. Don't go by that project. It's just that I want you people to. Okay. So I will have to first go to the drive. Just give me 1 second, guys. There is this project. I have done it. E drive, that is, yes. This is here. This is here. Here. Submission file. Yes. Yes, we have. Okay. So just you can notice these steps when you go into the project development. Many of you must have already gone into that part. Okay. So yeah. So here it is. So I'm just sharing one project. I'm just giving you a sense